Welcome. This is Mrs. Rutchling, Chapter 5, Polyatomic Ions. A polyatomic ion is a group of covalently bonded atoms, but they have an overall charge, and we treat them as one unit. You will not have to figure out the charge. You will just memorize some common ones, and we'll use them in our ionic formulas. Here's a list of common ones, and the ones that are highlighted are the ones that you are going to need to memorize. I want to point out that acetate has several different forms. You will see it written all of these ways. I prefer this last way because it is what organic chemists use, and this is an organic polyatomic, but these two are correct, and you may use those as well. A lot of times polyatomic ions are called oxyions. Now that's not necessarily always true. Most of them have oxygen in them. There are two polyatomic ions we use that actually don't have oxygen, so it's a bit of a misnomer, but you can use this oxygen pattern to help you memorize them. So if we look at chlorate, ClO3 with a negative charge, if we take one oxygen away, it's called chlorite. Same charge, just one less oxygen. And you can even take another oxygen away and call it hypochlorite. Remember from biology, hypo means less or under. And then we can do perchlorate, which has one more than the 8. We don't really have any to memorize that are hypo or per, but we do have plenty that are the 8 and the ite. So remember to look at that pattern. Here's another one. We have sulfate. It has 4 oxygens, and if we take one oxygen away, now we call it sulfite. So if you memorize the sulfates, you automatically know the sulfites by taking one oxygen away. When we use polyatomic ions in formulas, we just treat them like single ions. We're still going to cross over to write the formula, and if we have more than one, we're going to put it in parentheses. We only use that when we have more than one. For example, we have sodium nitrate here. Nitrate is a polyatomic ion, but there's only one, so no parentheses. However, down here, when you cross magnesium and hydroxide, which has a -1 charge, we end up having to use 2 of the hydroxides. And so we put that in parentheses to show that there are 2 of the complete polyatomic ion. Nomenclature, or writing their name, is very easy. They keep their name. We don't change them to ide, so notice we have nitrate, sulfate, hydroxide, chloride being a monoatomic ion. But here we have ammonium, and its name is also just kept the same. Here is a summary of what we've learned, and we know that they are ionic formulas because they start with a metal, or now we know that they may also start with the ammonium cation. We use the cation, then the anion. We cross everything to use the subscripts. If it has a multiple charge, you're going to be given the charge. And we use those polyatomic ions as a unit. And if we need more than one, we use parentheses. The naming is the same as we've learned. Cation name and then anion. Monoatomic cation, keep it the same. If it has multiple charge, we use a Roman numeral in the name only. The monoatomic anion is going to end in ide, and polyatomic ions keep their names. Let's give this some try. Pause the video and then compare your answers with mine. With aluminum nitrate, I use the charges and cross, and so I have 3 nitrates for every aluminum. I do the same thing for copper 2 nitrate, so I have the copper 2 ion, so I know I have a +2 charge, and when I cross, that means I'm going to need 2 of the nitrates for every copper to create a neutral compound. Looking at iron 3 hydroxide, once again, the Roman numeral gives us the charge for the cation, and when we cross, we have iron 3 hydroxides. Hydroxide seems to be the most difficult one for students to remember that it is a polyatomic and to put it in parentheses. I assume that it's because there aren't any subscripts and it makes it more difficult to remember, so make a note to yourself so that you can remember to do this. And lastly, we had tin 4 and hydroxide, and so we have 4 of the hydroxides to cancel out the charge. Pause the video and match the set with the correct name. Please compare your answers to mine. As we practice these, we'll use polyatomic ions that might not be on the list that I gave you in the notes. I have put in Class Notebook another more complete listing for your reference.